Hello students, welcome to the physics session. Uh, Now in today's session we will be discussing about the concept of potentiometer in the chapter current electricity. Okay, let us meet at 8:30. Okay, till then take care, bye bye. Okay guys, good evening everyone. Yes, sit down first. Right. So, previous class, what we have discussed? What was the last concept? Meter bridge. Right, what is Wheatstone bridge? And an application of Wheatstone bridge, that is meter bridge. What is meter bridge? And how to calculate an unknown resistance by using meter bridge. We have discussed the conceptual part, and if we do any numericals based on that, yes? Yes or no? Right. Next, now we will do we'll discuss briefly about what is a potentiometer and what are the few uses. What are few uses? What is the purpose of potentiometer? We'll see. So it is line is going on. Your voice will be yes. It's good. Your voice will be going there clearly. Yes. So potentiometer. So what is potentiometer? We'll see briefly, and some of the applications or uses of potentiometer. So write down heading, subheading potentiometer. So potentiometer is a device which is used to measure EMF of a cell or a source, EMF of a source more accurately. Right now, what is that? Potentiometer is a device which is used to measure EMF of a cell more accurately. Okay, fine. Then actually potentiometer also So potentiometer is a device which is used to measure what? EMF. You can say potential difference or EMF. Special case, potential difference can be called as EMF, right? So it is used to measure the EMF of a cell or a device more accurately. Right? And it works based on one simple principle. It says that when a constant current passes through a wire, then potential difference across any part of the wire will be proportional to length of the wire. That based on that principle, potentiometer works. Here, somewhat it resembles meter bridge, but both are not exactly same. How they are not exactly same? Let us see. In the circuit diagram of potentiometer, let us see. It will have two circuits. We call as primary circuit and secondary circuit. So primary circuit will have a battery. It will have some internal resistance, and it is connected to this. This will have some internal resistance also. It may have some EMF, or you can say the potential V, whatever it is. So here, this is connected between these two terminals, let us say A and B. Between these 2 points, a wire is connected. Here, it looks like meter bridge, which is having L-shaped, two L-shaped, conducting materials with the 2 gaps, left gap and right gap, and no distance will be connected on one gap, and no distance will be connected. Like it looks like that similar structure. Here a wire is connected, and that also a wire of 1 meter length will be connected. But here, this is a wire, is made of length more than 1 meter. That means this wire length, the length of this wire will be greater than 1 meter, maybe 5 meters or 10 meters or 8 meters, whatever it is. Right? And so in between these two, here we connect another battery or cell whose EMF is E, and it may have some internal resistance R, which is further connected to a galvanometer and hence to a jockey J, and hence it is connected to a jockey. This part is called primary circuit. Primary circuit is a brief representation. You may have internal resistance here and an external resistor and so many other things also you can take. Here some books will give you another external resistor also will be expressed series resistance or some RS. So it may have some internal resistance also. Got it? Similarly, here also some other extra even a key will be arranged. So different additional arrangements can be shown in different books. So this is basic circuit of potentiometer. And this part is called primary circuit. This is called secondary circuit. Secondary circuit. CKT means circuit. So draw that one. Okay. As I told, here you may have different resistance combinations with key, etc., etc., and you can have here also some other resistance like a variable resistor, like a resistance box or variable resistance itself can connect here. So different arrangements you can have. So this overall, this part of circuit is called primary circuit. This is called secondary circuit. And this potentiometer, in this potentiometer, if the total length of the wire is, if we take it as L, capital L, and this potential may drop, this potential will drop across the entire length of this. Okay? So, if that is the case, we can say that according to the principle of potentiometer, the potential across this length, where the galvanometer shows a deflection, zero deflection, we will call it as balancing length. You can take this as small l or x also. Let us take it as some x in this case, x. So, what you can understand here is, from this representation, if you arrange, it is better to have here one resistance, variable resistance or resistance box. So, this is a resistance box. High resistance box or some resistance box. If you change the resistance in that box at a particular value, so there will no current passes through this galvanometer. That means it shows a zero deflection. So at that particular point, or you can say for a particular value of resistance, for every resistance you have to slide this jockey from end A to end B. In that process, at some point, the galvanometer shows zero deflection. That point is called as null point. So this length of that wire and that point is called as balancing length. What length? Balancing length. So what you can understand here is, if the potential across this part of the wire V is nothing but potential per unit length of this into length of this will give you, so potential across the total length, if it is V by total L into length of this, if it is X, is equal to potential of this battery. It will drop exactly here. So you can take this as E. So if you don't know what is the EMF of this cell, you can calculate the EMF of the cell by using the principle of potentiometer. Principle of potentiometer says that potential drop across any part of the wire is proportional to length of that wire when constant current passes through that wire. When constant current passes, provided here, when constant current is passing, because of this resistance arrangement and what do you call it, sliding over this, and if resistance condition will be reached there, when constant current is passing, the current changes and hence finally becomes zero. So it will not give any deflection. So under that condition, you can say this is V by L into X is equal to E. So that gives you this. What do you call it? EMF is equal to V by L into X. So the V by L is called potential gradient. Potential per unit length or potential gradient. So change in potential with respect to distance will be called potential gradient. Or here this can be expressed as some K into X is equal to E. The K can be expressed as V by L. This is called as potential gradient, where K is equal to V by L is called potential gradient. Potential gradient of the wire. Potential gradient of the wire. This is basic idea of what we call potentiometer. And this potentiometer is used for different purposes. And that means for different uses. So the main uses of this potentiometer are to calculate the EMF of a cell and to compare the EMFs of, if you have two cells, to compare the EMFs of the two cells, you can make use of this, and also to find the internal resistance of a cell. Internal resistance of a cell also can use this. How? Let us see briefly, then you can work out some numericals based on different concepts. So write down some heading, uses of potentiometer. Uses of potentiometer. Uses of potentiometer. Uses of potentiometer. So we will consider mainly three uses. One is used to find EMF of a cell. EMF of a cell is used to find the EMF of a cell, and also it is used to compare the EMFs, to compare EMFs of cells, and also it is used to find internal resistance. It is used to find internal resistance. Is used to find internal resistance of a given cell. How to find the EMF? How can you use this to find the EMF of cell, and how to compare the EMFs of cells, and how to find internal resistance? Let us see briefly with the help of different circuit diagrams. So note down those points. Copy. So to find EMF by comparison of EMFs of cells itself, you can find out the EMF of one of the cells if EMF of one cell is known. That is one way of finding the EMF of a given cell. Whereas if a cell is given like this, directly you can find the EMF of the cell also. EMF of the given cell. How to find the EMF of the cell is, we know current is equal to net EMF by total resistance in a given circuit. You can say a primary circuit in this case. So by making use of that, let us see briefly for first, write down first subheading to find the EMF of a cell. To find the EMF of a cell. How can you make use of this? Directly you may get a question also based on this, generalized question. So find the EMF of the cell shown in figure, like a general circuit diagram also will be given. So let us see here how to find the EMF of a cell by using generalized circuit. Yes. Say if you have a battery and it is connected to a wire between 2 points A and B, okay, of length L, capital L, and its potential difference is V volts, and if this is connected to a cell of EMF E, and it is connected to, of course, a key and hence a resistor and hence a jockey, a galvanometer, and hence to a jockey. When it is sliding, the jockey is sliding on this, it will give a balancing length of X. If the potential of the battery is battery in the primary circuit is given, and this balancing length is given, and length of this wire is given, then if you are asked to find what is the EMF of this cell, so the question is find EMF of cell E. Find EMF of cell E in figure. Sometimes this EMF of cell will be given, V will be given, L will be given. We will be asked to find X. What is the value of X for which galvanometer shows zero deflection? By using the same condition which we are going to use here, you can find out that. So first let us see this. So according to this, our discussion in the previous circuit, what is this? Potential across this when you change, if you slide for a given value, if you slide this jockey here, so that at a particular point D or C, whatever it is, if that is at a length of X, if the galvanometer reading is 0, that length is called balancing length. So under that condition, potential difference across this length of the wire, potentiometer wire, can be expressed as V by L, potential per unit length into X, is equal to potential of the cell, which we don't know. If V total length and X are given, directly can measure what is this. E is equal to, simplifies, E is equal to V by L into X, we also call it as K into X. Sometimes instead of giving these values directly, you may be given the parameter called potential gradient of the wire is some units and balancing length is some value, then find the EMF of the cell shown in figure. Like that you may get the questions. So this is the expression we have used to calculate that. Got it? Based on the same concept, let us see another question, another kind of question. Write down. Find the value of X. Find value of X. Find value of X. In the figure, find value of X. Find value of X in figure for which galvanometer shows no deflection. For which galvanometer shows no deflection. No deflection in the person. So here, let me give you one simple circuit. So write down. Here we have a battery. You can consider this is a variable battery having a potential of 20 volts. It is connected to a wire is connected to a wire. This is a wire between these 2 points, between A and B. Its length L is equal to 10 meters. 10 meters, and this is further connected to a cell of what do you call EMF 8 volts, and it is having internal resistor. There is some resistance, and it is further connected to a galvanometer, so that here this is giving what you call balancing length at a distance of x from A, from left side or from A. So let us consider its internal resistance is some this resistor having some resistance of some 8 volt, something like that. This is 8 volt. Okay. So how to find what you call x? What is the value of x for which the galvanometer shows zero deflection? Here, if you observe, you have to remember that these potentials, the potential of this battery and this cell, if you observe, the battery potential to the left side is higher potential, this also should have higher potential. If this is having lower potential, this also should have lower potential. Okay? That condition you have to follow always. Remember, in case of potentiometers. Now, we are asked to find what is x. So, under balancing condition, so that what do you call galvanometer should not have any deflection, means no current should pass through this. If no current is passing here, potential across this is equal to potential across this length. That means potential per unit length E into x is equal to potential of the battery. That cell. That is the condition of this. Are you following? So here V is given as how much? 20. L is given as 10 into x is equal to 8. So how many times it goes? 2 ones, 2 fours. So x is equal to 4 meter. So for x is equal to 4 meter, we will get a null point, or we will get a condition of no current is passing through galvanometer. For x is equal to 4 meter for these given values. Is it clear, everyone? So this kind of questions you may get based on what you call these simple calculations. Calculation of EMF or balancing length. Calculation of balancing length. Next, let us see another one. Right. So next, write down for heading comparison of EMFs of cells. Comparison of EMFs. Comparison of EMFs of cells. Comparison of EMFs of cells. Next heading. Comparison of EMFs of cells. Comparison of EMFs of cells. Comparison of EMF of cells. How to do this process? By using potentiometer. So to compare the EMFs of two cells, some two cells which are having EMFs E1, E2, we have to have a primary circuit which will have, let's consider like this. The primary circuit is having these two cells like their lower potential and higher potential, having a potential V, and this is further connected to a wire here between the points A and B. It is, let us say, this is having length L. And following this, this is called primary circuit. The circuit is called what kind of circuit? Primary circuit. To this primary circuit, we can connect the cells whose EMFs you are supposed to compare. Let us connect here one cell whose lower potential and higher potentials. This is lower potential here. For this also lower potential should be at the same side. Lower potential whose lower and higher potentials of the cells are connected in such a way that its EMF is E1 and this is connected here. It may have some internal resistance. It is connected to some point 1, let us say. And Let us connect another cell whose lower potential is here and higher potential is here, whose EMF is E2. So that this is marked as point 2. So here let us consider a point 3. It is a 2-in-1 switch. Is connected to a 2-in-1 switch, and hence to galvanometer and hence to jockey J. So what happens is you can connect some resistance box and plug key also here. Resistance box and plug key to what you call make a proper arrangement. But the basic stuff we are showing in the circuit here. So now this is a key, 2-in-1 key. So if you close this onto this part of circuit will be closed, this will be open, this will not be included in the circuit. But if this is closed, so this part of the circuit will be closed, this will be avoided in the circuit. If this will be excluded, this will be excluded from the circuit. Okay, that is what you have to understand. Now, in this case, if key 1 is closed, if key 1 is closed, then this will be considered into the what you call circuit. And if it is closed and for given values of resistance etc., if you are sliding this and if you get a balancing length of, let us say L1, that means potential across this will be same as the EMF of this, because these two are in parallel. So what you can write here is potential of this is nothing but potential gradient V by L into L1. V by L into L1 is equal to E1. And you take this as equation 1. When E1 is closed, when 2 is closed, when E2 is closed, then what will you get here? When 2 is closed, this will be excluded, this will be included. So that potential gradient V by L into L2 is equal to E2 will get. You can take this as equation 2. So this will be closed. Okay, you can consider here internal resistance and all, just that part you just can only potential part we are considering here, without considering the resistances etc. Now, if you take the ratio of this, that is 1 by 2, implies E1 by E2 is equal to this. If you take to the left side, V by L into L1 by V by L into L2, V by L is cancelled, we get L1 by L2. So by knowing this, by knowing L1, so in first case, in second case, if this what you call balancing length is some L2. Second case, if the balancing length is L2. By knowing this balancing lengths for this what you call circuit having the potential of V, total length L, these EMFs can be compared by using this relation. Even out of these two, if one EMF is known, another EMF can be calculated. So if E1 is known, E2 can be calculated. So by using that what you call circuit arrangement, you can find out L1, L2. L1, L2 will be known. If E1 is also known, E2 you can find out. Or if E2 is known, E1 you can find out. So like this, you can compare the EMFs of two cells. What does this comparison means? It may be L1 by L2 is 2 or 1 by 2, something like that. So E1 is 2 times E2 or 1 by 2 times E2. This comparison you can do it. What is called comparison of E1? What is the EMFs of cells? Which is greater, which is smaller out of the given two cells. That is called comparison. And this can be do. You can do that by using this simple process. So this is how you can compare the EMFs of two cells. Note down that. Copy. Next write down the third use, that is you can use this potentiometer to find the internal resistance of a cell. Internal resistance. How to find internal resistance to this? So write down next subheading to find internal resistance of a cell. To find internal resistance of a cell. To find internal resistance of a cell. Write the heading to find internal resistance Usually internal resistance we denote by small r. Internal resistance small r of a cell. Of a cell. To find internal resistance r of a cell. Let us see how to find this. Let us see how to find this. A similar kind of arrangement only let us consider. Right. You see here. Let us consider in the primary circuit. In the primary circuit, a battery of potential V. Battery of potential V, which is connected to a wire. It is connected to a wire between point G and B. A wire of length L. Of length L. This is called primary circuit. This is called primary circuit. To find the internal resistance of a cell, we connect that cell whose internal resistance we want to find. Let us connect this here in the secondary circuit. Let us say this is higher potential. This is higher potential. Then also for the cell also have to have higher potential on the left side only, and vice versa. This is the EMF E of a cell whose internal resistance is small r. Let us mark that internal resistance here, small r. The following. This is further connected to an external resistance R, and then it is closed. This point or junction is connected to a plug key, and hence a jockey and some internal arrangement, and hence so galvanometer G is galvanometer, and hence to a jockey J. Is it clear, everyone? Yeah. Here one more point. The key here. This we will try to arrange one more key here. One key here. Are you following this? No need of this. If you want, you can arrange key 1, key 2. Otherwise, only one key is enough. This is a key K, plug key or tap key or whatever it is. You can call this as tap key. If you express like this, we call it as plug key. This is the key like this. We call this as tap key. If you tap it, the circuit will be closed. If you release it, it will be open. So it is called tap key. This is called plug key. Any kind of key you can represent here. Okay? Key. We have a key here. Now, what? We are asked to find what is internal resistance of this cell. To find internal resistance, same principle of potentiometer we have to use. What is that? Potential drop across any part of the wire is directly proportional to length of the wire. According to it, if a constant current is passing. According to this, potential per unit length, this the balancing length is small l. Are you following, everyone? If its balancing length is small l, potential per unit length V by L into L is equal to. Here we have to consider two conditions. When K is open, so the EMF, whatever EMF is there, as there is no current is flowing, so the entire EMF will drop here. Are you following that? So what condition will you get? It is equal to E. So what will you get? It is equal to E. Whereas if K, the plug key is closed, or if you consider key here, if it is open, this current anyway, this has to be in circuit. So let us replace this key to here, guys. To here. This, let us consider this is the key. Otherwise, this may not be included into the circuit when it is open. So when it is open, this resistance will not include, or this will include in the circuit. Whether it is open or this closed, this part, the cell should be in the circuit, should include in the circuit. So if it is open, this will be in the circuit, and hence potential difference V by L into small l is equal to E, capital E. Are you following? Whereas when this is closed, here we can write this first. When K is open, V by L into small l is equal to capital E. So no current flows, the entire potential will drop there. Potential drop across this is E only, that will drop there. Whereas if or when K is closed, when K closes, what happens is, of course, when K is closed and you are sliding the key, a point comes, gives you balancing length. balancing length. You can take L1 and the other case L2. Okay. But here, when it is closed under the balancing condition, no current flows here, the entire potential whatever it is here, that will drop here. But what is the potential between this point and this point? That is the main point. When this is closed, the current from here, it will flow in this circuit, but it may not flow to that because galvanometer is giving zero current. So that means a current is drawing from this, that current will flows here. When a current is drawing, potential difference across this will be, whatever it is dropping here, is nothing but E minus IR. That is a discharging condition. Cell will be in discharging condition. So in that case, you can write V by L into L2. You can consider that balancing length, you can take it as, in the second case, as L2. In first case, you can take it as L1. So V by L into L2 is equal to not E, here it is E minus I into small r. Let's say this is 1, this is 2. What is I here? What is I in this circuit? This is I, right? What is I in this circuit? By definition of in case of cells, I is equal to net field, net EMF by total resistance. I is because I is equal to E net by R total. E net is E only here, E only. And total resistance is, when current is passing here through these two resistors in series, R plus R will be total resistance. Capital R plus small r is total resistance. That is your E, because E is this, you substitute here and simplify, then you get internal resistance. How? That is try to understand. So equation 2 can be expressed as 2 implies V by capital L into L2 is equal to capital E minus I is E small r by capital R plus small r. E common here, we take this out. And to simplify, you can write this as E into 1 minus R by R, and cross multiply you get R plus R minus small r by R plus R. So here small r cancel, you get R by R plus R into E. This is the right hand side part. This, if you take it as E into small r by R plus R is V by capital L into L2. Let's say this is equation 3. You want to find internal resistance. Now if you take the ratio of 1 and 2, what do you get? Or 1 and 3. 1 divided by 3 or 3 by 1. Either way you can take. 1 by 3 gives you V by L into L1 by V by L into L2. V by L gets cancelled. Left hand side part. What do you get? L1 by L2 is equal to capital E by E into R by this. E gets cancelled. So you will get 1 by R plus R. This R plus R goes to numerator. R plus R by capital R. This can be further. Then following this further can be expressed as R by R plus small r by capital R. So 1 plus small r by capital R will get. Then following this. This from this, keep it here and send this one here. Then we get R by capital R is equal to L1 by L2 minus 1. Or L1 minus L2 by L2. So from this, internal resistance small r is equal to capital R into L1 by L2 minus 1 or R into L1 minus L2 by L2. This is how you will get internal resistance of a cell given cell. Got it? These are few simple uses of what? Simple uses of potentiometer. Okay? Right? So you try to remember these points, and direct questions you may come across based on the previous, we have did some two examples, right? Based on calculation of internal resistance also. If you have a cell of some EMF of some 10 volts and is connected to an external resistor of 2 ohm or some 5 ohm, whatever it is, 5 ohm, and its potential is some 5 volts. The length is 10 meter. Then what is the internal resistance of the cell, so that when the key in the figure is closed, the galvanometer gives zero deflection. Right? So you can write down one simple question example, then we can wind up. Okay? So with this entire portion is completed of this chapter. You can practice and revise the numericals based on the other parts. So write down one question based on this. Write the question and erase this part. Still copying? Anyone? Just fast. Did we do any examples based on how to find potential difference in a circuit by using circuit theory? Meter bridge based questions we did? Right. So I'm erasing this part. Okay? Write the question here. Find the internal resistance of the cell shown in figure. Find the internal resistance of the cell shown in figure. Find the internal resistance of the cell shown in figure for which galvanometer gives zero deflection or no deflection. Galvanometer gives no deflection. For which galvanometer gives no deflection when key K is closed. When key K is closed. Got it? That means you have to understand that it is open or closed, you have to compare and you have to use that relation. So provided it is given as 10 volts and length is 10 meter, right? Draw this figure. Again, once again, these values, and this is 5 volts. You have to remember always that while dealing with the potentiometer, this is battery, this is cell. Potential of battery always greater than the potential of cell. So this cannot be from 15 volts. So it should be always less than that. It is 10, maybe less than that, maybe 5 or 8 or whatever it is, less than that. And internal resistance we are supposed to find out. So capital R is equal to 5 ohm. Capital R is equal to 5 ohm. Right. So what is the value of what you call this internal resistance? So that here in the first case L1, in the second case when it is closed, we get another what you call balancing length L2. So L1 is given as Z is 2 meter and this is we are taking this as L2 will actually this is your L2, this will be your L1. This is L2, this is L1. L2 is 2 meter, L1 will be 4 meter. This will be L1. Draw this properly. When it is closed, the balancing length, second case balancing length will decrease. Initially it will be 4, then it will be 2. So what is, by making use of this, how to find internal resistance? Direct formula I can use as R is equal to capital R into L1 by L2 minus 1. Right? Is equal to what is R? 5 into L1 is L1 4. L2 is 2 minus 1. So it is 2 minus 1 is 1. So it is equal to 5 ohm. Internal resistance is 5 ohm. Internal resistance is 5 ohm. Okay? So here the diagram itself is giving so much data. So usually the question in the question descriptive part will be given more, but the descriptive part I have converted into pictorial representation. From the diagram you have to take the entire data. So here L1, L2 means you should understand L1, the balancing length with what is when K is open. When it is closed, the second case L means when it is closed, this balancing. Okay? Right. Next, let us see. Time now. I have to take another class now for students. Okay, we will see one more question based on circuit theory. One simple question. Can I erase this? Write down this example. Find VA minus VB in figure. Find VA minus VB in figure. Find VA minus VB in figure. VA minus VB in figure. Yes, go down. So here we have A. To this, a battery is connected, and it is connected to resistor. Another battery, another resistor, another battery in reverse polarity. One more resistor. This is B. This is B. Right. So the values of these potentials and resistors are: this is 10 volts, this is 4 ohm, and this is 2 volts. This is 3 ohm. This is 4 volts. This is 2 ohm. This is B, and current is flowing in this direction. Current is flowing in this direction. This is the direction of current, and direction of current. Okay, and here the current is. They are asked to find what? They are asked to find VA minus VB. VA minus VB. Current is given as I only. It can be given some numerical value. Okay, you can take the numerical value if the numerical value is given. Otherwise, you can take it as I only. Okay, let me give you a numerical value of some 1 ampere is flowing. So that what is VA minus VB. So you have to remember the sign conventions. According to sign conventions, when current is flowing from one point to point another point, that from where current is flowing, that will be considered as a higher potential. Higher potential. So VA is at higher, so you can write as VA is positive potential. Higher VA. This is higher and lower. So minus 10. For this it is for potential across the resistor. This will be positive, negative. So minus IR is 1 into 4 is minus 4. For this it is plus minus. Minus 2. For this is plus minus. So current into is 1 into 3 is minus 3. This is minus plus. So you get plus 4. This is again plus minus. Minus 2 minus VB is equal to 0 and 10. By using Kirchhoff's laws. Now minus 4 plus 4 cancel. So here minus 10, minus 5, minus 15, minus 17. VA minus VB minus 17 equal to 0 or VA minus VB is equal to plus 17 volts. This is VA minus VB in the figure. Okay? So this is how you have to deal with this kind of questions. This kind of questions are already asked in different previous exams, previous year's exams. Okay? So try to go through a few of this kind of questions and understand how to do this kind of questions. Okay? Right. I'll give you one simple example. You guys try yourself. Take this example. Say find VA minus VB. Find VA minus VB for the figure shown. Here we have a battery of how much? 4 volts and a resistor of 2 ohm. This is VB, B. This is A. So that there a current of 2 ampere is flowing. 2 ampere. So what is VA minus VB? Let's tell me, what is VA minus VB? What is VA minus VB? So this is VA. This is plus minus. So minus 4. This is current is flowing from minus to plus. So plus to minus, so minus. It is 2 into 2, 4. Minus 4 minus VB is equal to 0. So VA minus 8 minus VB equal to 0. Or VA minus VB is how much? 8 volts. That's it. Okay? Right. So I'm winding down. So go through similar kind of questions, few more questions and practice. Okay?